Hi guys, how are you all? How are you all guys? Hey geometry kids, let's go ahead and do. Hi guys.
Hello.
Hi, Miss Priya.
Okay, hi. How was the homework last week, Amma?
I found it easy. I just except the proofs, the proofs are still a bit hard.
Yeah,
to
Miss Priya, for the homework, even last week's homework, there was answers everywhere, so I just did it on paper.
What do you no? What is that?
There was
What is it?
there was answers all over the document, so I just did it on paper.
Oh, I see. I'm sorry. Okay, see, there was okay. Yeah, I see. I noticed it only when I was doing it with the other class. The thing is, yeah, I'll check whether I have a clean copy. Geometry Sunday, right? Okay. Which part did we do that? 3 and 4 we did down. Okay, did you have any questions, Dhruv? Sahana, I got your message, ma. Thanks for your message. Did you have any questions on 3 and 4, guys?
I didn't understand the proofs.
Oh, proofs. Okay, okay, we'll definitely do. We'll definitely go over it. Wait. If you tell me like that, I'll definitely go over it. Should I send the results of the test, right?
No,
I thought I did.
we didn't get the results yet.
I Let's go over it then. Before I go here, I thought I did yesterday. I can't say here, I can't send it here, but yesterday, meaning Friday, I might have released because when I thought, let me see. Maybe I'm incorrect. I don't know. Let's see. I'll check it quickly. Okay. This was a 40 question. Oh, yeah. You know what? I know why I didn't send. Okay. There were three that I needed to correct manually, the last three, right? Please let me correct the last three and then send it, guys. Okay. Coming to the test, the last three should be manually graded. So I will take my time. I told the same thing to them as well. Now, let's go to the 3 and 4 of quadrilaterals. Let's see what are the proofs that are making your life difficult. Ashrita, can you name a couple of questions that were hard so I can help on
Okay.
those? Or I'll choose 3 and 4, right, ma?
Yes.
Yeah, parallelogram proofs are always hard. Go ahead.
I think it was the part 3, questions 23 and 24.
They were difficult. Okay, I see.
I don't understand exactly how to do the proofs for parallelograms.
Yeah, we'll do. We don't need their, meaning it can be done in multiple ways, right? So let me go ahead. Can you see my board?
Yes.
Okay, let's try, meaning we don't have to follow their proof at all. Mitransh, you want to help me? Statement and reasoning. Let's start with what is given. One or two, if we try the same thing, you can follow. Now, Mitransh, what will you start with, Mitransh?
Um,
No, in a proof, what will you start with? I'm not putting
given
you under the
like
bus. I'm just discussing, and if you don't know, I'm going to help you. So go ahead. Don't feel.
put given
Yeah, given the
WXTV.
first. Yeah, WXTV and ZYVT are parallelograms. That's what is given.
Yes, Priya.
Yeah, ma.
Can I say the next one?
Yeah, you want to say the next one?
Yeah,
Okay.
the next one is DY and
1 minute, ma. If I were you, right, I would mark it because I'm very bad. I cannot relate. I get confused. So I will go ahead and mark like this. WXTV is a parallelogram. That means what? First, I'll mark it nicely. Parallelogram means sides are as well congruent, right? I'll mark it like this. Otherwise, it's so confusing. Then next one, Dhruv.
And
Mine. Sorry, sorry.
it would be ZY is equal to VT because opposite sides of a parallelogram are congruent.
ZY. Z. Oh yeah, this is also a parallelogram, right? Wait a minute, wait. This is also a parallelogram. So I would say this is the same as this. These two. Okay, go ahead.
VY is congruent to VT because of opposite sides of a parallelogram are congruent.
ZY is congruent to VT because definition of a parallelogram.
Yeah.
Okay. And then,
WX is congruent to VT.
yeah, WX is parallel to VT, is congruent to VT.
And that's definition of parallelogram.
Yeah.
And
Then
then and then you'd say VY is equal to WX because of transitive property.
WX, yeah. See, it is just a sequence, ma. From here, what and all you can derive, write it down here. From these two, what and all you can derive, write it down here, see whether it matches. But before seeing whether it matches, you have to make sure that you are arriving at this. Meaning, you have to think what has to be proven and then think about ways from here, I have to go here. That should be your target right from the start. So, this is transitive property. Any questions, guys?
Don't we have to do one more step of symmetry?
Which is symmetry, ma? Meaning, did I leave something? Which is
No,
symmetry?
that's proof that WX is congruent to ZY, but we wrote ZY is congruent to WX. Don't we have to flip it?
Oh, okay. Yes, or I could have written it like this, right?
Okay.
Meaning, I could have written it like this, right? It was my bad, I felt.
Okay.
Can I move on? Srishti, was the test difficult for you?
No, it wasn't that bad. I feel like it's everything that we've learned so far, so it was good.
Yeah, see, I don't remember, but on seeing your test, I thought I have to ask you. But others, I felt was okay. I'll see the test again and discuss Srishti next week.
Wait, what do you mean? Like, did I get many wrong?
No, I felt like you didn't give your best, but I don't know, ma. Okay, maybe I'm wrong. Hold on, I let me be wrong. Wait, I'll check now itself. Ashrita's was okay. Johan's was okay. Mitran's was really nice. Okay, all of you did good. Dhruv, all of you are on the same line. Oh no, okay, you did great, Srishti. Okay, yeah. Sahana did well.
Yeah, because everything, it was like a lot from summer as well, like things that we learned
Oh,
from summer.
yeah. I agree because it was all see benchmark 2 to 6 means right from the start till date, ma.
Yeah, I could
It
because
was a
I had like there was like two questions that I didn't really understand, but then like I just tried my best. I don't.
I see everybody did well. Meaning overall the test was. Meaning I felt happy about it. Okay, let's see. What did I do? Yeah, this is do this. Ashrita, I want you to try. Did you already see the answers, Ashrita?
No.
Okay, then we'll go ahead and do. Let's try. Statement reasoning. We'll start from the first, okay? Okay. Go ahead, Ashrita.
Well, we have the parallel BDHA, and then we have has
Give. Let me mark, man. Sincerely, I can't follow if I don't mark. BDHA. BDHA. Okay. Okay, go ahead.
and then we have the CA is congruent to CG.
CA is congruent to CG. CA is congruent, which is congruent, wait. CA is congruent to CG. Okay. Okay. They are wanting BDH and G. Yeah. BDH, BDH and G. Wow.
Wait, Miss Priya,
Uh-huh.
I don't angle A would be equal
1
to
minute. Dhru. I really want Ashrita to proceed. Is that okay, Dhru?
yeah.
Dhru, I know that you can do it, okay? I really, since she had doubts on it, is it okay for me to ask her to proceed?
Yeah.
Okay, go ahead, Ashrita.
Like, could we do angle A is congruent to angle BDH since opposite
Angle
angles?
A, is congruent to. So from here you're deriving it, right?
Yeah.
BDH. Why?
Opposite angles of parallelogram are congruent.
Yep. I'm shortening it. Don't shorten it in your school. Let me also write it like this. Okay, then think about, see, these two are colored, right? Clearly, I have to prove those two. So you have added this in place, which is good. But somehow you need to bring this in. What else is given? Can I use that to bring this angle? Yes, I can. Think about it. What else is given, Ashrita?
The CA is congruent to
Yeah.
CG.
Can I use that? What does that mean? CA is congruent to CG means what?
It's an isosceles. Right?
Yes. So what? Oh, that's given. I wrote. Okay. See, I should have written this here. Mm. Mm.
That
It's congruent to CG given. So what can I say about it? Triangle ACG is
isosceles.
mm. Mm-hmm.
Would angle A and C be congruent?
Why A and C are congruent? Okay, now maybe Dhruv can help us.
Since it's an isosceles triangle, angle A would be equal to angle G.
Why angle A is equal to angle G? Please help us. Meaning, tell
Because
us.
since it's an isosceles triangle, the opposite, like these two angles would be congruent to each other.
Makes sense. Okay, now Shruta, in an isosceles triangle, if these two triangles are congruent, angles opposite to equal sides are congruent, ma.
Okay.
Got it. So angle A is congruent to angle
G.
G. Angles opposite to congruent sides
Okay.
are congruent. Actually, in isosceles triangle. And then,
Now we can do angle BDH is congruent to angle G because of transitive property.
yeah, but here, Amma, this one, right? This one is basically, I can write it in a better way. This one, instead of this, I can quickly write it out as isosceles triangle theorem. Now you can say, yeah, this is common, right? So I can say BDH is equal to BDH is congruent to G. What is the property?
Not transitive.
Yep. Any questions, guys? Any questions? Srishti, Sahana, did you follow, ma? Okay. Do you
Yeah.
want me to revise? Do you want me to revise a couple more proofs, guys? Let me do more proofs. Parallelogram proofs is what you need, right? How about this? Yeah. That's a good one. Okay. Nice one. How about this? I don't know the answers, guys. We can do it together. Go ahead. Given DB bisects AC. DB bisects AC. That's a good one, actually. You know what I do? As soon as I see, I told you, right? DB bisects AC means I will. Oh, DB bisects AC. Please don't be very careful when you do that. DB bisects AC means these two are equal. And then they have also said 1 is equal to 2. Okay, now, whoever has not tried at all, can we proceed? Meaning, take turns, guys. And each of you should feel confident. Encourage each other. At the end of it, it's our team. Go ahead. Who wants to try? Statement, reason. If you don't know, the other person can always help. There is nothing wrong. Go ahead. Who wants to try, Ma?
Do we first write out the given and everything?
Yeah, let's write out. Oh, who logged off? I don't know. I don't know. I'll deal with it. Okay, go ahead. Yeah, let's not write everything. Meaning, let's see. What do we need? ABCD is a parallelogram. We have to prove. For that, what can we do?
Well, since they said that angle 1 is congruent to angle 2, can't the other two angles next to them also be congruent?
Not really, because you don't know that ABCD is a parallelogram. See, nobody told you angle A is equal to angle C, Ashrita.
Yes.
So you cannot say that. You got it, Ma?
Okay.
Yeah. But do you understand why you can't say that?
Yes.
Okay, good. Hmm.
Miss Priya,
Yeah, go ahead.
um, since DB and AC bisect each other, DE would be equal to EP.
Nobody said that. Who said that?
I thought it bisects each other.
DB bisects AC means AC is split into two equal parts. That's all.
I thought it meant they bisect each other.
No worries. No, meaning, yes, ma, they see, Dhruv, DB is a line segment that is cutting AC into two equal parts. That's all is given. It doesn't say DB is bisected by AC. It says DB bisects AC. You got it? Dhruv, did you get it or no? Still doubtful.
I got it.
What did you say, Dhruv? Did you get it or still
I
doubtful?
got it. I couldn't.
Okay.
Miss Priya, I have a question. Can we think of this technically as a transversal by extending A, B, and DC as the
Good
parallel
one.
sides?
So what do we do? That's a nice theory. So what do we do? That's true. Go ahead. What do we do?
So then AC will be the transversal, so can't.
AC is a transversal. So what? Go ahead. So let's go ahead. So you are developing from here, right? So let me write that down. 1 is congruent to 2 given. So what to do? Go ahead. What can you say then?
Can't you say that angle 1 would be supplementary to the other part of angle 2 to form angle C?
Not, no. You said AC is the transversal, right? That seems correct to me. If AC is the transversal, then what?
Yeah, can't we say that the this angle is supplementary to this angle?
You can't, ma'am. Why? How?
Because if this is a transversal, they would be same side interior.
Okay. These two are parallel lines. This is the transversal. Okay. This is the transversal. If that is a transversal, these two are same side interior, no doubt. But these two are same side interior. No. Uh-huh. Ashrita, this one and this one is same side interior, right, Ashrita?
Yeah,
Miss
that's what I was trying to say.
Miss
But
Priya,
you don't have an angle here, right? No, Ashrita, by proving that, what are you trying to do? Ashrita, go ahead. Meaning, I like your thought, but what are you going to prove by using that?
Because
Okay.
then,
Uh,
if that works, then this angle would be congruent to this angle.
Miss,
See, Ashita, you don't need to go with a same side interior at all. You can just go ahead with this and this, right?
Yeah.
Considering this as the transversal, see the two red angles. What can you tell about the two red angles?
They're alternate interior.
They're alternate interior angles. Okay. But anyway, they have already given these two. Okay. One is bisecting 2. The 1 is equal to 2, right? If 1 is equal to 2, which is the transversal? AC is the transversal to what? If 1 is equal to 2, AC is the transversal to which lines?
DC, and AB.
BC and AB. Good job. BC and AB. Ashtata, am I with you?
Yes.
So, what can I tell about AD and BC?
They're parallel.
They are parallel. That means what? Why they are parallel? Converse of alternate interior angles.
Yeah.
Theorem. Okay, now we have proven that one side is parallel. What else can I prove? They've said something which I have not used. What is that I have not used? I'll think about it. DB by 6AC. DB by 6AC means these two are equal, right? What I can do? I don't know. What I can do? I don't know. Let's see.
Wait, Miss Priya.
Go ahead.
Wait. Would this proof require like finding two triangles to be equal?
Two triangles to be congruent, right? That's what I'm also thinking.
Yeah.
There has
Yeah.
to be two triangles that are equal,
Like,
and then you will go ahead and prove congruence of one of the sides using CPT CTC to prove ABCD is a parallelogram. That's the only way I also feel. But which two? Good
yeah.
one. Very good one. Very good one. Go ahead.
So the vertical angles over here, like the DEA would be equal to CEB.
Very good one. So you can prove that these two angles are equal. Why they are equal? Why they are congruent?
Vertical angles.
Vertical angles. Angle 4 is congruent to angle 5. Vertical angle theorem.
And then you can say CEB is congruent to DEA because of
Okay.
uh
See, what is that? See, what is that?
wait, CEB is congruent to DEA.
CEB. I wrote it as
AED,
numbers.
AED.
What is that? CEB is congruent to AED, right?
Yeah.
Okay, I wrote it out as numbers. Let me take off the numbers. Go ahead. AED. Okay. Then what else?
And then you would say triangle CEB would be congruent to triangles AEC because of angle side angle.
No, 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 no. You have only two. What is that? You have only two. One is this through fully you have not proven. Before that you are jumping. I feel like it, but maybe I'm wrong. You can tell me. See the angles you have given, and you said one is equal to two. That's fine. What I am missing?
Oh wait, if AE is equal to AC.
AE is equal to EC. I forgot to say AE is congruent to EC. Why?
Definition of bisect.
Yeah, but before this, I really want to write out whatever is given. DB bisects AC given. Now, AE is congruent to EC. Why? Definition of segment bisector. Then,
And then you can say
with
just the
these three,
triangle.
yes, from these three, I can say triangle DEA is congruent to triangle what?
BEC.
BEC. Good job. Now they're congruent. So what can I say about?
Wait, we have to write the reason.
Yeah. So DEA is congruent to BEC. Now what can I? Oh, sorry. This one is what, Amma? SAS, right? I'm sorry. ASA.
Yes.
ASA congruence. And then what?
And then you can use you can use
Wait. Dhru, wait. I want somebody to think.
okay.
Who else can think with me? I will help, guys. Who else? I really want somebody else to think. That way, everybody learns nicely. So now, yeah, we have proven that the two triangles are congruent. What do? We have to prove it's a parallelogram. How to prove it's a parallelogram? Think through, meaning if I can prove, we already know the red color lines are parallel. If I can prove the red color lines are congruent, then it's a parallelogram. Is there a possibility for me to prove AD is congruent to CB? Is there a possibility for me to prove AD is congruent to CB? Guys, we already proved that this is congruent to this, right? The triangles are congruent means what? The sides are
Be congruent.
congruent. By what? Why? What is the reason why AD is congruent to CB? Why AD is congruent to CB? Why? We already proved that these two triangles are congruent by ASA. So what are these two sides? Corresponding parts of congruent triangles, right? Now what happens? AD is not only parallel to CB, but it is also congruent. So what? ABCD is a parallelogram from the definition of parallelogram. Make sense, guys? This was a difficult proof. Is there anybody who has not followed through? If you did not follow through, please tell. We can do more. We can do more. Shall I assign more proofs as homework, guys?
Yes, please.
Yeah. Okay. I'll assign more proofs as homework, but I really want to do more, I feel. Amma, is there anybody who didn't understand? You have to let me know, guys. Yes, no, Vibha, did you understand?
Yeah.
Okay. Sahana, did you understand?
Yes.
Okay. You can feel free to say this is not your school class or anything. No grades is with me. I'm not going to do anything. Okay, how about this? We'll do one more. The pure intent is for you to understand and do. That's all. How about this? Proofs in parallelograms are hard, ma. But once you see, the more you do, practically you'll get an idea of, oh, this proof is going this way. I can do. How about this? Oh, this is what we did? No. Okay, let's do this one. I feel like these are nice set of proofs. First, let me draw. ABCD is a parallelogram. ABCD is a parallelogram means clearly this is clear. ACBDG intersect at F. ACBD, EF intersect at F. Okay, what I have to do? EF is congruent to FG. EF is congruent to FG. I need to prove this. Whoa. Okay, I listen. I think we can do. What do you guys want to do? Are you thinking through or you want me to try?
Yes, Priya.
Dhruv, I want somebody to try, Dhruv, honestly.
Okay, so you can say DC.
No, I want somebody else to do, I said.
My bad.
No problem at all. Go ahead. Srishti, you want to try? Sahana, you want to try? Or Mitran, you want to try? I want you to learn, so it's okay. Just tell me the given. Ashita, you want to try? Who wants to try, guys? Otherwise, I'll let Dhruv try. That's all. He wants to try, and I'm preventing him, I feel now. Go
Yeah,
ahead.
I'll try.
Hmm.
Okay,
It's
ABC.
okay to go wrong. Make it wrong. It's okay. Go ahead.
So you just want given?
Given which one you want me to write?
Okay,
No, no.
ABCD is a parallelogram.
That one. Okay. Uh-huh.
And then the next one.
Next one, I don't want to write it yet,
Okay.
ma, because I don't see any use of it. I don't know actually. Let's
Yeah.
see.
Okay. And then AD is parallel to BC. So that would
True,
be
but am I
definition,
going to use that lady?
because that's the definition of a parallelogram.
Okay, I hear you. AD is parallel to BC. Okay, I think I'll remove some of mine because I don't feel the need. Go ahead. Okay, and then
Um, and then F is the midpoint of AC and BD, and then because the diagonals of the parallelogram like bisect each other.
I like the way you're going, Srishti, but we really want to prove that EF is equal to FG. So which two lines it is better to consider as parallel? I really like the way you're going. You're right, actually. Diagonals bisect each other and you can prove DF equal to FB. If you prove DF equal to FB or FA is equal to... Okay, go ahead. Let me listen to you. Go ahead.
Wait, but what, yo, sorry, what were you saying? Like, I didn't really understand.
Illama, you go ahead. Let me understand what you want. Maybe you're right. Go ahead.
No, I'm just fine. I'm just doing like it's just the information of the parallelogram, like the properties.
Okay, you're just writing it out
Yeah.
without intending to go here. You have to reach here.
Okay.
So
Okay.
think about
So,
that as well. You have to reach here. How are you going to reach here? You have to include this EF equal to FG somehow at the end.
okay, so AFE and CFG is ASA, I think, like angle siding.
Which two triangles?
AFE and
AFE, yeah, it's not a triangle at all.
oh
AFE.
no, yeah.
You see, even I don't know at this point, I don't know how to prove. I'm also checking. So don't worry about it that you don't know.
Miss Priya.
Yes, you
Um,
want to.
no, I'm sitting in my car, so can I not turn on my video?
Yes, ma, sure, ma.
Okay.
Miss Priya, I have a question. Since like all
Yeah.
of them were intersecting at a point, does that mean they're bisecting each other?
No, intersection is different from bisection.
Okay.
They can always intersect. But I
Okay.
don't think they should have explicitly said bisect. Intersecting means it just see these two lines are as well intersecting. Are they bisecting? No, right?
No.
So it's like that.
Okay.
But uh,
Um,
oh wow, this is a good proof. Dhruv, do you have an idea of the proof?
Uh,
But take your time. Take your time. Think about it slowly.
wait, so since there's a parallelogram,
Hmm.
DC would be equal to AB, right? And or it'd be parallel too.
Which one?
DC and AB.
Yeah, they are parallel and congruent. You can say.
Yeah. The
Yeah, I
same
would
for
see,
A.
Srishti, I would want to include that. You see, meaning we at the end, I'm going to go. What is to be proven? I will always check. Okay, EF and FG. So how can I include that? I would want to include these parallel sides. You got it, ma? Because if I talk about these parallel sides, I have nothing to integrate it with EF and FG. Am I making sense, Srishti?
yeah. Okay, yeah, I get it. But like,
Uh huh. So DC is parallel to AB. Okay, and then. Go ahead. So instead of saying AD and BC, I prefer talking about the other one. DC is parallel to AB.
Wait, Miss Priya,
Yeah.
I think I know something. You can find DC would be parallel to AB and congruent. So then you can say ACD would be equal to CAB because of alternate interior.
Good job. Wait. So I can connect them. See here, these two angles, alternate interior angles. If they give you parallel, something should be equal. So DCA is congruent to BAF. Why? Alternate interior angles theorem. After that,
And then CA would be equal to CA because of reflexive, and then DCA. Oh,
wait. What is that?
oh, I'm trying to find the triangles congruent.
Yeah,
Is that
which two triangles? See, we have proven that this is parallel. You said alternate interior angles. Angles are equal. Great. What else?
uh AC congruent to AC because of reflexive?
AC is congruent to CA. How is it going to help? But you
Then you
did not
can
use.
find the
See, you
triangle.
did not use the bisection. Oh, there is okay, but it's see parallelogram. It bisects, right? What will happen to this?
Oh yeah, those would be congruent. Right?
AF is
Congruent
congruent
to
to
FC.
FC. Definition of parallelogram. So wait, what and all we have proven now? Let's see this one. You've proven that these two are congruent and these two angles are equal. What else I can prove about those two triangles? This triangle and this triangle. Why I am choosing those two triangles? Because I have to get to this EF and FG are CPCTC. I have to prove. So that is why I'm targeting only those two triangles.
Southbound Line Road for 3/4 of a mile.
So now, can you tell me which one? What else I can do? See, I've talked about this and then they're congruent, I know. Is there anything else I can do about those two triangles? Yes, these two are vertically opposite angles, right?
Oh yeah, shoot.
AF, that's okay. AFG is congruent to
Continue on Southbound Line.
CFE. These two vertically opposite angles, right guys? They all intersect, right?
Oh yeah, and then they would be equal to each other. And then you can find triangles equal because of
Yeah, because this is angle, this is angle, this is side. I can say A, I don't know what I'm writing here, because I don't see the numbers. So AFG is congruent to this one. AFG is congruent to CFE triangle. Am I making sense?
Mhm.
What congruence is this, Mitransh? What congruence is this?
ASA.
Yes, ASA. Good. ASA congruence. Then what? It's very easy.
Would it be CPTs?
Yep. EF is congruent to FG, CPCTC. Make sense, guys? So once you want to prove the sides are congruent, then it has to be CPCTC usually. Okay. When you think about parallelogram, always think about diagonals being bisected or the sides being congruent or parallel. If the sides are parallel, then this should always strike you. Alternate interior angles or corresponding angles should always strike you better. Okay, can I move on? Okay. Now, let me give this as homework. Okay, we have done some good work now, meaning we have done some good thoughts for proof. Can I move on to the next topic? And then you are going to try come back with more proof questions next week. Is that okay? I think that should do good for you. Otherwise, we can't finish what we want to do. 3, 4 you did. Proofs was what was difficult. Okay. Rectangles, pretty easy, guys, but a lot of properties. One thing is a quadrilateral with 4 right angles and opposite sides being congruent. Let me close this. You're seeing my board, right? Okay. So rectangles are quadrilateral that have quadrilateral with four right angles and opposite sides congruent. Any questions on that? Now, coming to properties of rectangles. See, it will look pretty silly. Why am I discussing rectangles? At the end of it, the properties that we define here are much more refined than what we studied in elementary grades. Rectangle, what are the properties of rectangle? Meaning all properties of a parallelogram will apply to a rectangle, please. All properties of a parallelogram will directly apply to a rectangle. So what are the properties? Opposite sides are parallel and, can I say congruent? What else I can say? Remember the properties of a parallelogram. What else? Opposite angles. What do you say about opposite angles? Properties of a parallelogram. Opposite angles are
Congruent.
congruent. And then what
And
about
and the diagonals are also
consecutive angles? Consecutive angles are
Supplementary.
supplementary.
supplementary, and diagonals
Or
bisect each other
dissect each other.
because it's a parallelogram.
Yeah.
Okay, good. Now, with that, that's good. Now, WXYZ is a rectangle. WXYZ is a rectangle. Where is my screen? Yeah, here. WXYZ is a rectangle. WXYZ is a rectangle. Okay, now I'll draw that for you. WY equal to ZX. WY equal to ZX. WY is congruent to ZX is what you need to prove. W X Y Z. Can we prove that? Diagonals are WY and ZX. Did I draw it like that? WY and ZX. Correct. Can we prove this? Given is here. To prove is this. This is the diagram given. These are diagonals. What to do? We have to prove. What is that we have to prove? WY. Wow. WY is congruent to ZX. We need to prove. How to prove that, guys? Okay. As soon as I see that, I really think that they belong to two corresponding sides of two triangles. What are the two triangles?
Wait, it's WXYZ is a square. I mean a rectangle, right?
Yeah, that's what is given. See, as soon as I see what needs to be proven, this WY and ZX, I can clearly see that those two are the corresponding sides of two triangles. So if I can prove those two triangles are congruent, I can always use CPCTC. Does it give you clue, Mitransh, Vibha?
Wait.
The two black color sides are the sides of two triangles, the corresponding sides of two triangles. What are the two triangles?
Wait, Miss Priya, wanna just feel like this V X XW is equal to YZ, and then VW would be equal to YZ YX, and then this line would be equal to this line by reflexive. And then you can say XWZ would be congruent to XYZ because of side. And then you can use a CPCTC to wait, never mind.
No, you're right.
Yeah.
But I think the sides that you chose are incorrect. Okay, just go ahead again. Let's go ahead. So first let's write down WXYZ is a rectangle. Okay. See, parallelogram, but rectangle is also a parallelogram, guys. That's why the proof is a little tricky. WXYZ is a triangle, then is a rectangle. Then what? Given. What do I say because of that? Go ahead, Dhruv. You seem to go in the right route. See, these two sides are common to which triangles? Think about it. These two sides are the correspond. They are the hypotenuse, like, right? They are the longest sides of which two triangles?
Oh wait, Z
That gives you the answer.
XWV and XYV.
XW.
Wait,
XW?
no, X. Wait, no, my bad. Z YVW
YZ?
W.
Oh, you want to take those, huh? Okay, I was thinking about something else. I'll go with you. I was thinking about XYZ and WXY. I was thinking. I'll go with you. I know what you're thinking. You're thinking about these two, right? This one and this one is what you're thinking. Anything is okay, right? That is also fine. The green and the rose triangles is fine. Let's go ahead with yours. Go ahead, Dhruv. So what do you want to say? You can clearly say ZX is congruent to XW. Why? Definition of a rectangle. Opposite
Yeah.
sides are congruent. And then what?
Wait,
Then what? ZW is congruent to WZ, reflexive property. The base, right? They're equal.
mm-hmm.
Then what?
Wait, yeah, and then we're doing
We need to prove this angle, right? Somehow we need to prove which angles are equal. With this we can't prove, right? Only two things we have. What are the two things we have? We have one side congruent. This
mhm.
is reflexive. So, there's one more. It's a rectangle, right?
Yeah, so
What can I say?
uh
What happened to the
WB,
angle?
yeah, they're right angles.
Hmm.
So then each one would be like wait.
Z XZW is congruent to XWZ is 90 degrees. Definition of a rectangle, right? Then what? SAS, right?
Yeah, oh yeah, SAS
So can I prove that XZW is
would be
congruent to XWZ
mhm.
triangles SAS? Now
And
what
then
can
you
I
can use CPCTC to find YW
Yeah,
WY equal to
WY is
yeah.
congruent to ZX by CPCTC.
Yeah.
Is that easy? Are you able to keep along with me, Ashrita? Are you able to?
I'm lost.
You're lost. Okay, no problem. I'll go over it again.
All right, Miss Priya, I have
Yes,
to
you
go
can
now.
go. Dhruv, you can go. I think you're following. I can.
Yeah. Thank you. Bye.
Okay, now let's go ahead and try this one. Uh, Sahana, you're also lost.
A
Mahi,
little
you're
bit.
lost. Ma, please open your mouth and tell I'm here to listen, guys. Who followed? Who didn't follow? At least tell me that. I'll get the help of whoever followed. Who followed? Who didn't follow? Mitransh, you got it?
Yeah.
Okay, then let me get your help. Okay,
I mean,
WY.
I got confused at the last part of the triangles.
No problem. Then I'll help you then. The first part you help me. W, X, Y, Z. If it's a rectangle, what are the properties first? Let me go ahead and write it down. These two are parallel, correct? These two are congruent. Then this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. Are you all with me?
Yes.
Okay. So the first statement would be WXYZ is a rectangle given. Okay, I used whatever is given. From there, I have to develop the entire proof. They are asking us to prove WY. They are asking us to prove that the diagonals are congruent in a diagonals are congruent is what we need to prove in a rectangle. Okay. But when you look at it itself, clearly, those two lines, the dotted lines, are are a part of these two triangles, which are congruent by themselves. Which two triangles? The orange and green triangles. Am I making sense?
Yes.
But if I want to say by CPCTC of these two triangles, that is the longest side, right? So I can say that they are congruent. For that, I need to prove that these two triangles are congruent. How to prove that these two triangles are congruent? I know this is a rectangle, so I can convert this as a transversal. When I convert it as a transversal, this angle mm,
That would be congruent to this.
which one?
Right
No,
here.
no, let's not go there. Let's not go to that angle because I'm not going to see. If I want to do alternate interior angles means it goes out of the two triangles. This angle goes out of the two triangles. So it's no use. Am I making sense, Ashruta?
Okay.
Yeah. So I'm not going to use that. It's useless. So I want to do useful things only between the green triangle and the orange triangle. Okay. One thing is very clear. The corner angles are all equal, correct?
Yeah.
Let me write that down. YZW is congruent to XWZ is equal 90-degree, right? And moreover, it has all four 90-degree angles. Definition of parallelogram. Definition of rectangle. Okay. That one I have proven. And then I also know I can clearly say YZ is congruent to XWY. Why? This and this are congruent. Why?
Because they're parallel.
Yeah, the parallel sides of the rectangle, right? So yes, from the definition of rectangle, you can clearly say opposite sides are parallel and congruent, right?
Yeah.
Then you have two things done. One is one side and one angle you have proven. What else you can prove? What is the leftover side? This is the only side left over and is common to both the triangles.
Yeah.
Yeah, so I can say by reflexive properties, ZW is congruent to WZ.
I don't get that part. Like, why are we using reflexive there?
Oh, okay. Why do you use reflexive there? Good question. This is YZW. Okay.
Yeah.
The other one is ZXWZ. Okay. When you say the order of these two triangles, right, from up down, YZW. Here it is XWZ. So when I think about the ZW, it is WZ on the other triangle. Do you see it?
Yeah.
That's why I'm saying reflexive property. Make sense?
Okay.
Since they are equal, then since they are congruent, so we proved that this side is congruent, this side is congruent, and this angles are congruent. So what is the
That'll be SAS.
exactly SAS congruence? WZ, I'm sorry, YZW is triangle YZW is congruent to triangle XWZ. Make sense?
Okay.
Now this dotted piece is congruent to this Y. YW is congruent to XZY. Why? We already proved that the triangles are congruent.
CTC.
CPCTC, that's all. You got it? Sahana, are you with me or lost, ma?
I'm with you.
Wait, so doesn't CPCTC like proof that like two sides of a triangle are congruent?
Yeah, that's what we proved here, right? Two
Yeah.
sides of the considered triangle are congruent.
Don't they have to be the same side on both though?
Yeah, that is the same side, right? Okay, Ashrita, why are you getting confused here? Meaning, see, YW, first and the last. YW, XZ,
Okay.
first and the last.
Okay.
Since we are considering triangles like this, it is making you confusing, that's all. We are not considering two different triangles. That's the problem for you. We are considering this triangle and we are considering this triangle. That's why it's causing confusion. You got it?
Okay.
This side is common. We prove that this sides are congruent already and the angle, this angle and this angle are congruent. Make sense?
Okay.
Since the triangles were congruent, we were able to say this and this are equal by CPCTC.
Okay.
Make sense?
Yes.
Okay, but you know what? Wait, we did not do. Oh my goodness, we did not do much. Okay, I just want to go over the properties of square because I really want you to get going with the last two parts of this. We dwell around already, we go slow, so let's see. Oh, rhombi. There's no square. Okay, rhombi is there. And then 1 second, guys. Rhombi. Oh my god. And then okay, I'm not going to give you proofs as for this week, okay? But I really want to cover rhombi. Okay, the last proof piece we'll do it in class first, okay? Again, there's a lot of proofs coming. Here they can ask any number of proofs, guys, but we will go over the properties of a rhombi alone because that will help you solve some more. Let's see. Properties of rhombi. Okay, how about this? A rhombus is a parallelogram with four See, one thing what I want you to remember for your life is this one. See, when it comes to a parallelogram, right? It can be split into rectangle, rhombi, square. Make sense? All are parallelograms, guys. Rectangle is a parallelogram, rhombus is a parallelogram, square is a parallelogram. All properties of a parallelogram applies to these. So here as well diagonals bisect each other, here as well diagonals bisect each other, here as well diagonals bisect each other. Got it? But whereas in a rectangle, the diagonals are also congruent. That one additional property is there. Diagonals are also congruent in a rectangle. Make sense? Now, coming to the Yama,
Can diagonals be congruent in a square and rhombus as well?
diagonals are congruent in a square is correct. But the diagonals congruent in a rhombus?
No, I don't think so.
In a rhombus, I have to check. Diagonals bisect, but diagonals, I don't think they are congruent in a rhombus. Uh, we will discuss the properties of rhombus. First, I need to make sure diagonals of a rhombus. I don't think so, ma, but I can check diagonals of a rhombus.
I don't think they're congruent.
Congruent or not, I can check. I don't want to misguide you. As much as I know, no, but before telling you that, I want to check. Diagonals of a rhombus are not congruent, ma. See, that's what I'm saying. Each of their specialized property differs and we'll have to respect them. Meaning, while the parent property applies to all the three children, here diagonals are congruent. Okay, diagonals bisect each other applies to all. Here diagonals are congruent. Here diagonals are congruent. In a square, diagonals are congruent. Make sense?
Okay.
Rhombus, the diagonals are not congruent. Make sense? I verified it as well. Can I go ahead? Okay. What did I want to finish? Let me see. Wait. Properties of a rhombus I want to tell you. All the four sides are equal, right, guys?
Yeah.
All the four sides are equal. I want you to know in a rhombus, okay? Because for proofs, it is so important to know that all the sides are equal in length. Okay. But for a rhombus, properties of a rhombus, four congruent sides. Diagonals are perpendicular. Diagonals are, see, as I said, right, parallelogram, the parent split into three children. Okay, square is very special. Okay, square is a parallelogram, square is a rectangle, square is a rhombi, square is everything. All properties of, let's write it down, wait. Rhombi, rhombus and rectangle. Okay, Here, when you think about it, we all know parallelogram says diagonals bisect each other. That we know. Opposite sides are congruent. Opposite sides congruent, you know. This applies to all of the children. Whereas here, diagonals are congruent. Diagonals are congruent. We just now learned. The thing is, diagonals bisect each other is applying from the parent. But see, like you inherit from your parents. Okay, all the properties of the parent applies to you. But you have your own special properties based on the environment you grow. That is not attached to your parents. So that is always different. Diagonals are congruent applies to this. Here, do you see rhombus has diagonals are perpendicular. Diagonals are perpendicular. Here again, diagonals are congruent. Now, the children, whether it is you and your brother or you and your sister, right? You don't need to have the same properties. Rectangle, rhombi, and square are like that. Any questions? Any questions?
No.
Okay. 1 second, guys. I really want to challenge you on one thing. I'm checking. Okay. I have a question. I said that this is the last question, okay? I said that the square is a rhombus, square is a rectangle, square is a parallelogram. So should I say diagonals are perpendicular here or not? Should I say or not? Can I say this? Is this right or incorrect?
They
What
should
are-
be.
It's
Yeah,
right.
yeah, it's right. I have to say, so the diagonals are congruent and perpendicular in a square because square is the youngest child of everything. Square will obey the properties of a parallelogram, of a rectangle, of a rhombus. But rectangles or squares are like sisters and brothers. You cannot compare them. They will have their own properties. Square is everything. So it has this, it has this, it has all of this. You get it? But rectangle and rhombus only has from its parent. And then they have their own special properties based on the environment they grow in. You got it? That's how I remember this. Will you all remember this?
Okay.
Yeah. So if you can remember like this, parent and children, it will work nicely. You won't forget things. If you have any questions, let me know. Okay, remembering this is the hard part. Okay, but remember it as a parent and children. Who is a parent of who? What can I attribute? All parents' properties apply to children, but siblings need not be the same. That's it. Okay, any questions for me? Okay, guys, I think I took too much of your time. See you all next week.
Bye, Miss Priya.
Bye, guys.
Bye.
Bye, Miss Priya.
Bye, guys. Sahana, are you over? She's gone.